Right now, you exist. That sentence sounds obvious. It sounds like the most unremarkable thing anyone could ever say. But physicists have spent over a century staring at that fact with something close to terror. Because by every law of the universe they have discovered, you should not be here. Nothing should be here. Not the chair you are sitting on. Not the planet beneath your feet. Not the galaxy stretched out across the sky. According to the deepest equations we have ever written about the nature of reality, the universe should have destroyed itself in the first fraction of a second after it was born. All matter and all antimatter should have met, annihilated each other in a flash of pure energy, and left behind an empty, dark, perfectly symmetric nothing. And yet, here you are. That is not a poetic observation. It is one of the most serious unsolved problems in all of physics. Scientists call it the matter-antimatter asymmetry problem. And the answer, if there is one, may rewrite everything you think you know about why anything exists at all. To understand it, you need to go back, not just to your birth, or to the formation of Earth, or even to the beginning of stars. You need to go back 13.8 billion years to a moment so extreme that no word in any human language is adequate to describe it. The Big Bang. In the first billionth of a billionth of a billionth of a second, the universe was not cold and dark and empty. It was a seething fireball of energy so dense that every point of space was indistinguishable from every other point. There were no atoms yet, no protons, no electrons, just raw, screaming energy. And then, as that energy began to cool, something extraordinary happened. Matter appeared. According to the laws of physics, whenever energy condenses into a particle of matter, it must simultaneously produce a particle of antimatter. They are mirror images of each other, equal and opposite. An electron carries a negative charge. Its antimatter counterpart, the positron, carries a positive charge. A proton and an antiproton, a neutron and an antineutron. Every particle born in the Big Bang should have had a twin born beside it. And when matter meets antimatter, they annihilate completely, without remainder. They convert back into pure light and leave nothing behind. So here is the problem. If the Big Bang created equal amounts of matter and antimatter, and all the physics we know says it should have, then every particle of matter in the universe should have found its antimatter twin, collided, and vanished. The universe should have run its entire story in under a second. Born, destroyed, gone. A brief, perfect, self-erasing moment of existence with no one left to notice it ever happened. But something went wrong, or rather, something went beautifully, inexplicably right. For every billion pairs of matter and antimatter that annihilated in those first moments, there was one extra particle of matter left over. Just one. A tiny, almost invisible imbalance. An asymmetry so small you could search for it your entire life and almost miss it. That leftover 1 in a billion became everything. Every star in every galaxy, every mountain on every world, every ocean, every cell, every thought you have ever had. All of it is the debris of an ancient imbalance so small it should have been a rounding error. The question is, why did that imbalance exist? In 1964, two American physicists named James Cronin and Fitch made a discovery that sent shockwaves through the scientific community. They were studying the behavior of particles called kaons, unstable subatomic particles that flip between matter and antimatter states, and they found something deeply strange. The kaons did not obey perfect symmetry. They decayed in ways that were ever so slightly different, depending on whether they were matter or antimatter. This was the first experimental evidence that the laws of physics themselves treat matter and antimatter differently, not by much, but by enough. Cronin and Fitch won the Nobel Prize for their discovery, and the implication has haunted physics ever since. The universe may be fundamentally biased toward matter, not by accident, not by chance, but baked into the rules at the deepest level. The technical name for this asymmetry is CP violation, a violation of the symmetry between charge and parity. It means that if you took a mirror image of a particle interaction and also swapped its matter for antimatter, the process would not look identical. There is a measurable difference. The universe, it turns out, is not perfectly balanced. But here is the maddening part. The amount of CP violation we have measured in particle accelerators is not enough. Not even close. The tiny asymmetry, discovered by Cronin and Fitch and confirmed by decades of experiments at facilities like CERN and Fermilab, accounts for only a tiny fraction of the matter-antimatter difference needed to explain the universe you live in. There must be more asymmetry somewhere, a source we have not yet found. This is what keeps physicists awake at night. Somewhere in the laws of nature, hidden in particles or forces we have not yet detected, there is a deeper bias toward matter, a reason why the universe chose existence over perfect, symmetric oblivion, and we do not know what it is. Some physicists look to the neutrino, a ghostly particle so light it barely interacts with anything, passing through entire planets as if they were made of nothing. Trillions of neutrinos are passing through your body right now. You will never feel a single one, but neutrinos may hold a secret. Experiments like T2K in Japan have found hints that neutrinos and antineutrinos behave differently from each other, a form of CP violation that might, if large enough, explain the cosmic imbalance. The results are tantalizing, but not yet definitive. Physicists are watching. Others look at a hypothetical period in the early universe called the electroweak phase transition, a moment when the fundamental forces of nature were separating from each other, and the universe was cooling from a uniform plasma into distinct fields of gravity, electromagnetism, and the nuclear forces. Some models suggest that this transition could have created the asymmetry, like a bubble of broken symmetry, expanding through the young universe and leaving matter in its wake. But current models do not produce enough asymmetry to match what we observe. The answer is still out there, and this uncertainty should not make you feel small or insignificant. It should make you feel something closer to awe, because the fact that you exist is not a guarantee. It is not the inevitable outcome of the laws of physics. It is a narrow, improbable, unexplained exception to a universe that was trying its hardest to erase itself. Think about that for a moment. The universe was running toward symmetry, toward balance, toward a final state of zero, and something stopped it. Some deep asymmetry in the rules of reality tilted the scales by 1 part in a billion, and from that tilt, over 13.8 billion years, came hydrogen, then helium, then stars, then heavier elements forged in stellar furnaces, then rocky planets, then oceans, then chemistry, then biology, then you, sitting wherever you are right now, reading these words. You are not the product of design or accident in any simple sense. You are the product of a cosmic bias so slight it barely qualifies as a preference, a universe that almost chose nothing and instead chose everything. There is a thought experiment sometimes attributed to physicist Paul Dirac, one of the founding architects of quantum mechanics, who once said that the most important thing in physics is not the equations that describe how things behave, but the question of why the equations take the form they do at all. Why these rules and not others? Why a universe that allows matter to persist rather than one that guarantees its destruction? No one has answered that yet. But every experiment that probes the heart of a proton, every neutrino detector sunk beneath a mountain, every particle collision at the Large Hadron Collider is asking the same quiet question. Why are you here? You started this with a fact so obvious it felt like nothing. You exist. Now you know that this is not obvious at all. It is the single most improbable, unexplained, and magnificent fact in all of physics. The universe had no reason to choose existence, no reason to tilt toward matter, no reason to leave behind the residue that became everything you know and love and are. And yet, here you are, the impossible leftover of a universe that almost wasn't.